we would like to keep an important role for the nuclear energy in the energy mix of tomorrow for Europe, because it is delivering green energy. And then it can be, if it is combined with the renewables, the right approach for that, because we have to be careful and aware if for these intermittent sources of energy we are going to build either coal plants, either gas plants, we are going to build them to operate for 50, 60 years. So we can't say we are decarbonizing and building things producing CO2. So there is also, we are aware that nuclear accidents are scaring everyone, even ourselves. We are not supermen, we are scared about nuclear accident, even if we are working in the nuclear. And so, just after Fukushima, it has been pointed out by Daniel, the platform ourselves, we have looked what are the consequences of Fukushima accident and what should be implemented in existing reactors, but also the one that we are designing for the future. So the lessons learned have been straightforward, translated in 2013 with a series of, research programs or new procedures introduced to all our partners. The SNTP fully aligns the strategic objective to support the utmost level of nuclear safety and security together with the set plan objectives and increase the sustainability. And on the top of that, we wanted actually to use at maximum the European legal and financial instruments which are available in the framework program and the EU to maintain this safety and security at the highest levels. We contributed also to the set plan, and in particular the key action 10, by producing many documents, reference papers, and we contributed to the set plan what should be the priorities to respect this approach of safety and security, which is the same for all the countries in Europe, but also to the different technologies, and we have provided that actually in due time to the set plan program. Now coming to the pillars, I will go very fast. The Nugenia, which is addressing today's technology reactors, is looking to, among others, the LTO, the long-term operation of our nuclear power plant, and the consequences in terms of safety, the behavior of the materials, especially if you are going to long-term operation, and gathering industries, utilities, research centra, and academia. That's the 4 arrows you see here, where all of them are working together to generate the best knowledge, but also straightforward applied on the existing reactors. Today they have 103 full members and 7 honorary members which are from abroad, outside Europe, and 26 countries are represented among those. And this pillar, we have turned it into a legal entity in 2013. The pillar on the innovative fast neutron spectrum machines and closed fuel cycle, we have there 4 projects that we wanted to do as what we call the European Sustainable Nuclear Industrial Initiative, because in the set plan we were also asked to come with industrial initiatives associating industrial partners, research centra, academia, on specific large projects. 4 projects are actually conducted under ESNI. the Astrid reactor, a Gen 4 reactor design based on sodium technology, the Mira accelerator-driven system, which is dedicated for closing the fuel cycle, the Alfred LED technology, and the Allegro, which is a gas-cooled fast reactor technology. These are 4 projects which are the backbone of this pillar and working on real projects, not only developing techniques or technology and with teams around. The third pillar, NC2I, which is dedicated to the cogeneration and going beyond electricity production, is today focusing on the heat generation, but at the extreme objective we have there is the actually the hydrogen production would be the goal. And we have there initiated even a collaboration beyond Europe towards the United States, the NGNP Alliance. These are a series of things that milestones we accomplished since the very beginning. You see all the documents that have been produced. I will not go in detail about that. But let me move, what are then the challenges for this platform and to this industry and how they correlate later to the nuclear safety and security. Is there a solution for the nuclear waste? That's the first question we continuously are getting in front of us. Is it worth to continue with this energy source whereas the uranium reserves are for limited time? Is nuclear fission energy compatible with the energy mix of tomorrow, the renewables, etc.? But we have to answer those questions without putting in jeopardy the safety and security. And so how are there really solutions, or are there ways to address that? Actually, in Daniel, his talk, he says we need to be flexible. If the nuclear cannot be flexible, we will try to see. About the waste, we have solutions. Geological disposal is already, in demonstration in some countries. Exactly the same as CCS that we were talking about this morning. And what is the issue there? The issue is the public acceptance. And actually that was said this morning that CCS in Metz was refused for NIMBY reasons. So it's exactly the same thing. We have direct disposal of spent fuel, we can do. We can do reprocessing and vitrified waste, but we can even go beyond that and do the partitioning and transmutation to reduce even more the footprint, and that will result in this. Actually, we can store safely. The only thing that we are keeping the radiotoxicity for 300,000 years, and we have to put that in the geological disposal. Second thing, and I speed up, I understood, if we vitrify, you get to 10,000, you do the transmutation, you get to 300 years, which is a human time scale and not anymore geological time scale. The reserves of uranium, it can be a concern, but if you go from the ones through in thermal reactors and you will be finishing your uranium by 2100, and you turn to fast reactors, you can go for thousands of years. The third, compatibility with the energy mix of tomorrow, grid follow-up, so more demanding, so we have to go more flexible, and that we can do it with fast reactors. And we can go also small modular reactors that do the job. The capital-intensive investment and long lead time to get to the production can be also addressed through the SMR. In conclusion, innovation can be triggered by external or internal parameters. The new demand can be the trigger. or new constraints can be the trigger, or new opportunities. And three of them are available to the nuclear technology to be innovative. So, nuclear fission community, industry, research centra, and academia are ready to do it. And the SNETP and this nuclear community has contributed to support the key action 10 for the set plan, the nuclear safety and security. And in the second conclusion I have is some recommendations where the key action can be helpful for us as a community and as a, I would say, a platform. I listed there some topics that could be of interest. I will not read them, but they are more for the conclusions. So SNETP is 10-year-old this year, like the set plan. So I would say happy birthday for both of us, set plan and the platform, on behalf of all the members of this platform, which are very long list you see there. Thank you very much.
Thank you very much, Hamid. Happy birthday. And thank you also for the list of issues from your perspective and your platform's perspective, which merit attention for the future. Let's quickly go to the next speaker to have some time in the end for questions and discussion. Our next speaker is Peter Lischka, who is the Vice Chairman of the Board of Directors of WUJE. He's also a member of Euratom's Scientific and Technical Committee, so he is actually at a very high level involved in advising Euratom and the European Commission on scientific and research issues. So I think he's very well placed to add to the discussion, and I'm looking forward to hear your perspective. The floor is yours.
Thank you. At the first, I would like to say that I am a regular participant of these SETPAN conferences since the beginning, I think 2007 or 2008, and was the first conference organized, and also I was a member of team which also established a sustainable nuclear energy technology platform. It means I am quite familiar with the situation in nuclear in Europe, and I think also familiar with the situation in the energy sector or electricity sector generally in Europe. My information is divided to two parts. One part is connected with the safety culture in operational nuclear power plants, and the second is about the research in nuclear in Slovakia. Why I decided to speak something about safety culture. Generally, during the last decade, maybe more than a last decade, the number of technicians between the top managers, generally in companies, is falling down, is less and less. And the same is also in the companies which operate nuclear power plants. And I think it is not very good for a safety culture, but I would like to say that these managers which have not any technical experience with operation nuclear power plants, or they have not the technical background what concerns the safety of nuclear power plants and so on, must be responsible for their behavior, because their behavior is very important for influence on the culture in a company. It means if the behavior and words is the same, that is a positive and a good impact. And this is a brief description of the base for a safety culture, but I don't like to give you a lecture about the safety culture, but only to speak about the behavior and work and works of leaders. Leaders go by example, demonstrate and convey expectations. It means if the behavior and words of leaders are different, these have a very bad influence on the behavior of technicians and other people in nuclear power plants. And these points which are here are very important as a message for leaders. The safety culture system, hard facts in a company, may be improved during a short time. It means if people are not very familiar with rules of a safety culture, it is possible to train them and to explain them and speak with them, and people in operation nuclear power plants will be more convenient for a safety culture and contribute to the safe operation of nuclear power plants. And the right spirit in the company and right attitude of individuals is affected especially by the top management behavior. It means the behavior of a manager is so important on the real behavior of the people, technicians and operators. And failure made by top managers and differences between their words and real decisions have a major negative impact on the company atmosphere and attitude of individuals, and correction of the top manager failures is a very long-term process. You know, as I told that the training of technicians or staff is quite not for a long time. It is possible to organize or improve very quickly, but the impact of the not correct behavior of top managers has a long-term impact on the behavior of people. I don't want to speak about the real company. It is not a speech about the company which operate nuclear power plants in Slovakia or on the neighbor countries, but it is a general message that the behavior of top managers is very important. It means between these top managers must be enough technicians with experience, with knowledge, with background for operation of nuclear power plants. That's all about the top managers in companies. Of course, I'm open for a discussion and so on, and something more about the research in energy sector and especially in nuclear branch. I think the organization of a research project in European Union is not very well organized, because the most of the projects are mostly for meetings and do some small works, and not to do some deep and big or huge research to, for instance, to construct something more than up to now, and so on, so on. Only several projects are quite good, but it was supported by structural funds, of course, and it was a national projects. It means I would like to say to people, the European Commission, please look better for administration of this research project, and to give more stress for real technical work in this project. What concerns the project in Slovakia, these projects are funded by structural funds or by Nuclear Regulatory Authority, and the goal was increasing of security energy supply. It means that no distribution of our electrical systems, and increasing nuclear safety during seismic event, and research of gas